So could I ask Marco, Jane, Andreas, and Tyge to switch on your cameras, please? Good. Okay, so now it's 2 o'clock and we have all the panelists here. It's very good. It could be that there were some participants who have joined a little bit later, so I will introduce the panelists. We have Marco Giacomazzi from the European Biogas Association. He's a policy officer there. We have Jane Hoffman from the Coastal Union, Germany. We have Andreas Musculus from the Institute for Agricultural and Urban Ecological Projects at the Humboldt University of Berlin. And then we have Tyge Kjær from Roskilde University. I have prepared one question to you each, and that we will use as some kind of icebreaker, and we will give some time to the participants if they want to submit questions using Slido. It's in no special order. It's how I put the questions here on my paper. So the first question goes to Marco Giacomazzi from the European Biogas Association. Which are the main barriers or challenges to harmonize the regulations for digestate utilization in Europe? So please, Marco.
Thanks, Jörgen. That's the million-dollar question, of course. Of course, there are many barriers and many challenges, starting from the fact that the new regulation adopted by the Parliament and the Council in 2019 will establish simply an optimal or optional harmonization. It means that although the European regulation will apply, all the national regulations will still be in place and then will find application in national judicial system, which means that a manufacturer, for instance, from France, he could decide whether to comply with the requirements of the national regulation and therefore putting his product and placing his product only on the French market, or he can choose to comply with the requirements of the European regulation and therefore placing his product across the whole common market, and so it can be sold in France, in Germany, in Denmark, in Sweden, everywhere. But this is of course a choice of the manufacturer itself. So it may depend from the technical and economical perspective also whether it's more convenient for him to what market address from his production. And of course another barrier very important is the current pandemic, because as I explained before, the implementation of the European regulation will require member states to do some homework. From a bureaucracy and administration point of view, they need to implement center requirements, they need to establish bodies, they need to establish procedure for recognizing that products fulfill certain requirements, but of course everything now has been delayed, and therefore we hope that by the deadline, by July 2022, the situation will be solved and everything can go according to the plan.
Okay, thank you very much. I think all of us cross the fingers that the pandemic will be resolved. The sooner, the better. The next question goes to Jane Hoffman. So, which are the main health and safety aspects when collecting cast seaweed? Please.
Thanks, Jürgen. Yeah, this is looking at it from a slightly different perspective, I think. So from the demand and collection side. The reasons perhaps why we are even sitting here. Obviously, the tourism industry is a great driver for the removal of beach wrack and public perception. The perception of risk with beach wrack is generally unjustifiable. I think that's what we can ascertain, that in normal circumstances, as beach wrack's lying on the beach, it doesn't cause any real health risks. But to say that obviously this changes in certain circumstances, particularly with quantities that are lying on the beach wet for any length of time. So when we talk about health and safety issues, I think we're looking at access to the bathing waters. This is one problem that the municipalities need to take into account. Obviously, they need to do regular assessments of their beaches for sediment transport and any dangers to bathers, and this would also include any large movements of beach wrack that have landed on the beaches as well. And then obviously we've got the pollution side of things, which the pollution that we can normally see that might be hidden, so macro litter, particularly sharp objects, both on the seaside, so the sea-sourced litter coming from ships, and also then from glass and sharp objects which have been dropped and mixed up in with the beach wrack. So that's maybe the obvious things. But then when we come to the pollution that we can't see, this is where it gets a little bit more, I guess the risks are higher then. You have sewage contamination. This is one thing that's been highlighted, and there are some quite a few studies on this. And there's suggestions that beach wrack might be a contributing factor to elevated levels of fecal indicator organisms within sand. I don't have any figures for this, but this is suggested. And also, obviously, high concentration of coastal birds can also lead to pollution by feces within the beach wrack itself. There's agricultural and industrial runoff can pollute the organic material. But I think one of the main ones that people are actually worried about is the gases given off due to decomposing seaweeds. It doesn't smell very nice. When hydrogen sulfide, it's fairly toxic. It smells a bit like rotten eggs, and that can really be problematic. And I think a lot of people associate large quantities of beach wrack with that smell, and a lot of people will have smelt it. And it is an irritant to the eyes and respiratory tract, so it can be problematic. But we're talking about large extreme, cases. Normally, it's not a problem.
Okay, thank you. I will not try to give any feedback or anything, because I see that there are questions coming on the Slido. So I will continue to Andreas Musculus. Which are the main barriers for increasing the digestate utilization in Germany? And it can be technical issues, regulations, policies, etc. What do you think?
Thank you very much, Jürgen. Well, we have 9,000 biogas plants on farms in Germany, so there is already quite a lot of digestate on the market. And at the end, it's a question of what the farmer actually needs. What kind of fertilizer does he prefer? And that, of course, refers to a lot of technical characteristics. So if there's a lot of water in, that's no good, because it's expensive to transport. If there's a lot of carbon and nitrogen together in a bound form, this is also critical, because the farmer is only allowed to put a certain amount of nitrogen per year on his land, and this refers to the total content of nitrogen, which may not contribute to plant growth. I mean, nitrogen that's bound to carbon. So I think a lot of technical issues are the barriers. If you are able to convert the digestate into a mineral fertilizer that has that is what the farmer wants to have, and what it has a nutrient composition, nutrient distribution of what the farmer would like. I think that would be easy to put that on the market and even gain the market price for it. On the regulations, I don't see so many problems, and also on the policies. So if you have a fertilizer that can be put on the market, that is equal to all the other fertilizers that are sold. So I think the biggest problem is technically, and is getting the water out and getting digested in the form that the farmer would buy.
Okay, thank you very much. And then the last question to Tyge before we open up for the participants. Which were the main challenges in terms of regulations in Solrød in Denmark to use digestate from co-digestion of cast seaweed as a fertilizer? So please, Tyge. I think you have to switch on your microphone.
The answer is simple. All the regulation is depending on a linear economy. The reuse of seaweed is a question of circular economy, and most of the regulation is not in favor of that. For instance, we have an input regulation and we have also an output regulation, and it makes it very complicated. Maybe there will be a new way, maybe the harmonization of the fertilizer, as you mentioned, Marco, will change the whole picture. But I have seen that there is a lot of regulation which is not in the line with the circular economy thinking, which I think is the important part here. But when it comes to the, I think one of the basic problems we have had is the waste directive, because it sets up certain rules for waste. Municipality is not supposed to handle waste if you could recycle it. So if you are recycling the seaweed, the municipality is not supposed to do that. I mean, we have a lot of nonsense regulation put in from old thinking, and I think that there's a lot of things to be done here to make it simple or to make it functional. I've just mentioned that one of the starting points for this was just mentioned it to Jane, that one of the starting point for our journey on the seaweed was the local health authority says that the gas from the depositing of the seaweed, they dig it down at the nearby the sea. It creates a lot of gases, and they ask the municipality to do something about it. So it's obviously already known, as you mentioned, that there could be this kind of health dangers. But just to answer it, it's simple. I think we have a lot of regulations going in different directions. They have been historically needed when they was developed, but they're not related together. The nitrogen regulation, the water framework regulation have all their own, so to say, thinking. It's we call it silo thinking, that you have one thing and then another and then another, but you have to integrate it at the local level, and this is very difficult. And I think there might be possible to go for a development like the integrated coastal zone thinking, including, of course, other topics also. So this is maybe the short thing. We have to change most of the regulation, also from the seaweed point of view, but also from other points of view.
Okay, thank you very much. And I don't know if Angela, are you able to show the Slido questions? Yes. And the panelists, are you able to read it as well? Okay, so the first question goes to Mr. Musculus. Did you investigate the direct use of macroalgae/seagrass for soil improvement? Or do you know a research group working about this?
Yeah, thank you very much for the question. I'm sure it has been done, but not by us, and I cannot remember actually a group who did that. But organic amendments, there was research on that for 100 years or more then, and we are unfortunately just far away from the sea to deal with this kind of substrates.
Okay, and then you have one more question. What do you think is the most promising technical option for more valuable fertilizer?
Yeah, that's a difficult one, and there's probably not a simple answer to this. So I mentioned one of the biggest problems is the water content, and then the share of nutrients you have in the digestive that may not fit your requirements. So you either have the choice to get the water out and then have an organic material that you may further need to process, or you use technologies to extract simple nutrients, like we do a vacuum degasification. That means we bring the ammonium into the gaseous form and then use an acid stripping and get 80–90% of the ammonium out. And then you have a clear mineral fertilizer, but also a rest. I think that there will always be more than one nutrient streams coming from these units. And the challenge is to put them together in a way that they can be used as a fertilizer. So you may add other nutrients from other sources and at the end have a fertilizer that fits the use you want to have it for. At the moment, I think when you look at digested or slurry processing technology in Germany, the focus is not so much on nutrient recovery, but unfortunately on the cost side, so on reducing the nutrients when it comes to nitrogen and also phosphorus and in particular carbon. So burning it and using the ash would be an option that would be economically feasible, but from the environmental point of view, maybe not the best. But I don't think there's one single promising technology at the moment.
Okay, thank you.
I would like to add that one of the things we are doing is to look at the input to get out the output of phosphorus and nitrogen asked for by the farmers. And this is maybe a more efficient way because you're not losing anything and you're not adding an extra process with the energy use. So that might be an option.
I didn't quite understand that. Can you explain, please, how you mean looking at the input?
You regulate you have different substances for the input, and you set the input together so you get the needed level of nitrogen, the needed level of phosphorus, or the reduces phosphorus. And it is also a question of cooperation between different biogas plants to do that, because in some areas they have too much phosphorus, in other areas they're lacking phosphorus. So this is the way to do it, to cooperate on the input side, to get an output fertilizer with the quality asked for.
Well, the main business of a biogas plant is selling the electricity or the heat or the energy, and for that reason they used to take whatever material they can get in order to produce the energy. But I fully agree that there should be more emphasis on the output and on the digested as a byproduct and not as a waste.
No, the input. It's a nitrogen content, the phosphorus content in the input part. So you get out the output at a certain level, at a certain declaration level, related to the region you are working in.
Yes, but at least when you use agricultural input, you have not much choice using the input. It's chosen on the basis of what gives you the highest methane yield, and not so much on the phosphorus content.
This is because you're using maize as a plus substance. If you use other material, you could get, as you shown on your picture, you could get other quality of the output.
Yes.
If I may also add just one point from the European organization perspective, also listening to what our members are discussing recently, it's important, of course, the possibility to generate electricity from combined heat and power, but we really see a mentality switching in the last years, and we see that all around Europe there is a lot of interest to generate biomethane from biogas, and it doesn't really change the reasoning, in the sense that you always want to get the feedstock that allows you to collect the bigger amount. So of course you want the feedstock that allows you to get the bigger revenue at the end. But just for clarifying that nowadays we see also this very important change in biomethane, and just one quick remark from my side on the first answer that Andreas gave to the question when was asked about the barriers also for the use of fertilizers, that he said farmers want performing product, and they want to be sure that about what they put on the field. We also have sometimes the perspective that farmers have a sort of misconception about digestate, that they see that if it comes from waste, it is of a low quality compared to mineral fertilizer, but we know that this is not necessarily the case. So of course it's important the upgrading of the digestate, and we take part in different projects financed under Horizon program for studying how to do the upgrading of the digestate. But we think also that a change and the promotion of the utilization of organic and recycled fertilizing product, it will be important, because they actually work without like harming the environment, actually saving many environmental impacts, and in any case delivering a good result.
Yes, but the farming is a business in the first hand, and the farmer has to make decisions on the basis of finances, and only in the second hand may consider environmental impacts.
Okay, we have more questions coming in here. We have one: is there any difference by law perspective among macroalgae in water coming from storm missions, and beach wrack in shallow waters and beach wrack on the beach? And I think perhaps Jane, you could at least the difference between beach wrack in the water and beach wrack on the beach, if there is any difference.
Well, obviously there's a huge difference in that the word beach is a huge indication that we're talking about material that is on dry land and not floating or suspended in the water. So yes, there should be a definite line or differentiation between the two. Obviously, for recycling purposes, particularly for biogas plants, it would be nice to have as least sand as possible, and so removing it from the water would be ideal. However, this depends very much on the location and the country. For example, in Germany, this is not allowed. In Denmark, I know that there are areas where It is accepted to remove the material from the water, but really this is a different topic because, well, certainly from the contra perspective and our project perspective, because we're looking at, there are managed beaches where beach wrack is problematic for the tourism industry, and this is a resource that then can be used. It's being removed anyway. If you then actively go and search for the material, it's a different mindset. So if you're taking it out of the water, so yes, and with the law perspective, it depends on where you're talking about. So different areas have different laws covering this. Yeah, so that's really what I can say.
There is differences from country to country, but I think there is also another important differences. If you take the microalgae fresh from the water, you will have a certain gas level. If you take it from the beach, it will be around half, depending on how many days they're going, but it goes very, very fast. So it becomes, from a gas point of view, unuseful material if it has been on the beach for a longer time. Yeah. And then you have got the smell too.
But this is something that I mean, I'm not an ecologist, a marine biologist, but I think there was so little information on the shallow waters and what the impact would be, that this would need to be really looked into before it starts in any way, you know, commodifying algae that's floating in the water.
And then we have a quick.
Sorry, Jürgen, may I just give a quick answer to the comment from Andreas before that farming is a business? I'm sorry, but I know this is a panel debate, so I wanted to debate because of course I agree that the farming is a business, so the operator need to look at financial aspects and at economics. And this is the problem, right? Because in order to compete on the market, you cannot expect, especially in agriculture, that your commodity will have a super high price from which you will get a super high revenue. Because at the end of the day, like the agriculture commodity, we know what are the prices, because also you have a lot of competition. So in order to get more efficient and more effective in your production, what can you do? You reduce the costs. And this is the point, because when you have digestate, as you said, you have the water content that you need to get rid of. And therefore, if you want to get to the same amount of nutrients that you would get with the mineral fertilizers, you would need to buy more digestate than you would do. So you will actually increase the cost of production. But this is the problem in our society, where we have recycled products that are very good for the environment and are very good for the circular economy. But if you want to go in that direction, you will finally like spend more and have a more expensive or costly product. And this is exactly the problem, that we cannot value the positive impact of digestate, that nevertheless is a very efficient and good product, or at least this is the view that we have. And I agree in any case that the upgrading is a very interesting opportunity, but at the same time I see also that that is not only how to say a justified choice. Sometimes you also have farmers that believe that digestate, since it comes from waste, is not good quality, which is not the case.
I
Okay.
will support what you are saying, Marco. And I think that our agriculture development has been to increase efficiency through chemical components. Now we're going to change it. We're going to expand the value chain. Instead of just producing food, the farmers could also produce fertilizer, etc., etc. This is just your point, Marco. We have to look from a completely other direction for the development of our farming system, because our seawater is not. I mean, it was mentioned that the load was falling in Germany, but it is not the case. If you look at the figures, it is increasing for the last three years. Danish measures says the same. So we are on a wrong track, and I think the track Marco is pointed out is the right one to go, even for the German agriculture.
Okay, I think it would be different if the agricultural sector had to pay for the nutrients that goes into the water in a linear way.
Yes.
Then there would be an incentive. But anyway, let's move on to what is actually the difference between seaweed and algae. Do anyone in the panel wants to answer it?
I'm not an expert at all. However, I do know that seaweeds are a group of algae. This I do know. So algae is kind of like the umbrella name. Seaweeds are only found in seawater, funny enough, that's the name, whereas algae is found also in freshwater. And please don't question me on this because I don't know much more information about it at all. But seaweeds are autotrophic, and that but some algal species rely on external food sources. If that makes sense, I hope so. I think we just said
it makes sense. The seaweed is not a family name. Algae is.
Yeah, basically. The really important aspect is to differentiate then the seagrass from the algae, because that really is something completely different. Yeah.
There is a different discussion on eutrophication. Maybe it would be an idea just to have a discussion on it. The nitrogen is creating seaweed. This is not a position from the EU. There's an EU handbook. It says it is opposite. The nitrogen is killing all the other plants and all the other fauna in the area. So it's only the part of the material that are nutrition tolerant. That's the concept they're using. They are spreading. They are growing. Due to the high level of nitrogen, and it might be interesting just to ask you, Jane, about this thinking. That instead of saying, well, it's the nitrogen who is creating the seaweed, it says no, it's the nitrogen who's killing all the other things, including, of course, the small.
As I say, I'm not an ecologist. I know that there are a few ecologists in the audience, so I've got to tread very carefully. But as far as I'm aware, that when you have high nutrient levels, you're more likely to get high concentrations of microalgae. And actually, yes, if you have macroalgae in seagrass growing and coming up ashore, it's actually a good sign that the water quality is not necessarily too bad, particularly seagrass. So because these both macroalgae and seagrass rely on good water turbidity, so clear water, because they require sunlight. So if you have a lot of microalgae in the water, which does feed on the nutrients, then you will get poor water clarity, and then less macroalgae and seagrass growth. So that's how I've always understood it. But further than that, I can't answer the question. I'm sorry.
Okay. So we have another question here. Who is collecting or cleaning the beaches today? And where to is all the seaweed going today? Is there anyone who wants to pick up the question?
Yeah, you'll find that the majority of managed beaches, and when we say managed beaches, they're normally tourist destinations that have a problem with large quantities or problematic beach wrack. And so most coastal areas are affected by or have managed beaches. Where it's going to, well, that depends on the location. At the moment, it's just dealt with in a lot of cases like normal compostable organic waste, municipality waste, that's how it is classified under the EU waste catalogue, and that's how municipalities deal with it. Obviously, throughout history, there's been a long or historic use of it direct on fields. This has been restricted somewhat due to fertilizer regulations, that they can't just keep throwing it directly on the fields. Although I know in Germany that there is now permits in place where they can apply for direct use permission, but they have to prove that the nutrient levels are certain and the pollution levels are under certain thresholds. So, it very much depends on where and the location as to what actually happens to it at the moment. And obviously, with the more and more stricter regulations and the more aware we become of particularly the nutrient cycle, then the municipalities are looking for worthwhile options, and hence the interest in in our projects. So, yeah.
In our area, we have 4 ways of using it. The one is digging it down on the beach. This is a neighbor municipality doing, and it creates awful smells. The other one is landfill. This is our neighbor south who is doing that.
A shame.
The third one,
what a waste.
the third one is burning, but they stopped it because it kills the scenery, the salt.
Yeah.
And the fourth one has been a direct use of fertilizer for non-food production. And I said they're still using it, but it's only a smaller amount because of the regulation you just mentioned, Jane.
Yeah.
But this is the 4, and it is in a small area, and I think it is about costs, the cheapest way.
Yeah.
I have a question that connects to that. So if I remember being at the sea, actually there's plastic everywhere, and we had the problem that when we use municipal waste in the biogas plant and then using the digestive on the field, the levels of plastic and other impurities are a big challenge and are a big problem, actually leading to the fact that it's virtually impossible to do that on land in the same way. To what extent do you consider the plastic in the substrates that can be collected a problem? So do you think this will be a major issue, or can it be handled?
For me, or for the biogas plant?
I think
because the farmers is eager to know if there are any plastic waste, and it was very, very small amount, but they have to sort it out before they deliver it if it's plastic larger. But if you go to the North Sea, you will absolutely find a lot of problems with the plastic, especially with the small pieces of plastic from the plastic industry.
Yes.
And they are so small that you cannot discover them by just having a look. So I think that seaweed in the North Sea will be a no-go until you find a way to separate it.
Yeah.
That's interesting. So that's also one more argument for processing the fertilizer. If you get the nutrients out and maybe getting rid of the rest in a different way, you may solve the plastic problem.
Yeah, I think it will be an option for we have made a study on the plastic in the North Sea coast and Danish North Sea coast, and there is a lot of, it is depending on the stream, the water stream and the weather it goes in, but it comes from the UK, Holland, maybe Germany and France. We could see it from some of the declaration that it comes from France, and it's a huge amount coming up, and it will be a complete mixture. So I think the point you have there is that you have to go for another technology in order to use the seaweed there.
Mm. And another point,
it can also be that other, how to say, sorting technologies may be implemented either in the sorting before the digestion process or after, because as you are doing upgrading of the digestate, you are adding a step. I see in that case that a simple mechanical process that will remove the plastic that you have in certain circumstances might be simply implemented. The point is that sometimes is not always available such kind of technology, or is extremely expensive. So it's difficult to share the burden of this investment. But of course, it always depends also what is the feedstock that you're using in your digestate, and if you use exactly let's say organic residues that you collect from the shore, or when you cut the grass from the street, it may happen that you find bigger pieces of plastic or smaller pieces of plastic in bigger quantities. But for instance, when you do separate collection from household, and when you have a functioning scheme, for instance, in the city of Milan in Italy, or in the Flemish region, or in certain part of in Austria or in Germany, you have actually very good result and small level of impurities that are already sorted out in the first sorting process. So it depends also a lot on the feedstock, but I think that certain sorting technologies can be implemented.
Just one thing I just wanted to add was obviously the processing and sorting is a really includes really expensive steps, and this is really problematic. And I think another thing that needs to be addressed is when the local managers are actually cleaning their beach, that they have this recycling mentality in their mind, that they have an overview of what actually is going to happen to the material. So that can include sand, and limiting and trying to reduce the amount of sand in it, trying to reduce the amount of litter. And this isn't, or hasn't happened yet. That the municipalities and beach managers are just cleaning it. They want to get rid of it as quick as possible and just get it off the beach. Really, this is a real grassroots kind of mentality that needs to be also like this knowledge shared, that if it's going to be recycled, then the collection process can also be helpful as well.
But Andreas, what would be the fertilizer value from a pyrolysis process? You were just presenting some of the ideas. What would it be useful?
Yeah, we did some research on biogas, what's it called, biochar, from pyrolysis, or from the other liquid process. No, it's exactly the other way around. If you stabilize this carbon and make a char from it, it works like a sponge and takes all nutrients, or a lot of nutrients from it around. So it may happen, and happen in our experiments, that you have a negative fertilizing effect, and you need to add even more fertilizer in order to balance for that. Of course, during the decomposition of these materials in the next 20 years or so, there's a release of the fertilizer, but there's very little control of the release. And the farmer needs the fertilizer on time during crop growth, and not in the winter and not in other times. So I don't really see this as an option at the moment. But I know there's some research done on that, and we also did feed experiments with several sorts of biochars.
Because it could be a solution on the litter. I mean, we will have the litter in the sea for many years. We have spent 350,000 tons, EU says, of plastic in the litter, and we will come up not at once, but for the next 40 coming years, even though we stop today. So we will have the challenge to find other ways to do something with the material in the area with high level of litter.
That's interesting.
Okay, so with those interesting remarks, I think it's time to finalize the panel debate. So thank you very much for your contributions. It's always good to discuss these matters, and we have heard a lot of interesting things today. So thank you very much. And then I have the pleasure to introduce the last speaker. And it's Timo Gerrels from a company called KSVTC Tech. And it should be related to the Contra project. And I see that there is a presentation here. Could we get you on picture as well? If you can turn on the video, if possible. Yeah, perfect. So, with those words, I'm happy to leave the floor to you for your presentation. So, the floor is yours.
Thank you and good afternoon, everyone. My name is Timo Gerrels. I'm an environmental engineer working for KSVTC Tech. I know that's a complicated name. And we are dealing with the promotion, engineering, and sales of carbonization systems, especially vapothermal carbonization systems, which is more or less a thing that we invented. The vapothermal carbonization is a thermochemical process that copies the natural process during that nature makes coal from biomass over millions of years, and we do that during high pressure and high temperature at 220 degrees and 23 bar during a reaction time of around 3 hours. That works with almost or with every biomass, and that's why we decided to take part in the Contra project to check if marine-borne biomass like beach wrack, seaweed, seagrass, algae can also be carbonized in order to make biochar, which can be used in different ways. Instead of just getting it, collecting it from the beach and trying to decompose it somewhere in the backland. The process during which you could say easily, we bake the biochar from biomass, raises the concentration of the relative concentration of carbon inside the biomass molecules. Since we cannot make carbon out of nothing, that of course means that we have a total loss in biomass compared to biochar. We fill the reactor, heat it up, wait for like 3 hours, 4 hours, and then the biochar is already ready and can be gotten out of the reactor. What is biochar? Well, biochar can be used, that's our main focus, as a solid fuel to substitute, for example, fossil fuel, fossil coal like hard coal, lignite, brown coal, in power plants, heat and power plants, in industrial combustion systems like cement factories and all kinds of industrial furnaces that are classically or conventionally fired with coal. Biochar can also be used as a soil improvement agent. That is not the focus of our work. We are almost exclusively in the fuel thing, but there's many work groups working on the effects that biochar that is mixed under soil, not as a fertilizer, but as an improving agent to improve water holding capacities and things like that. There's an interesting project called the Stockholm Biochar Project, where they found out that that's where the lower picture comes from in the screen, where they found out that if they plant trees in the city, which is obviously expensive, they want the trees to hold up for many years. So they start with a layer of biochar under the actual soil, and that has been a great success for them. They are still doing that. Also, biochar can be used for different purposes, like a base reagent in chemistry. It can be activated to activated carbon. There is universities working on that. We are working together with some of them, but that's not ready yet. I wouldn't say that's possible on an industrial scale yet. This is the reactor that we used within the Contra project. So the material was collected at the beach, transported to our facility, and then treated in this little experimental VTC reactor. It has a 15-liter reaction chamber, and because of the size of it, it was a lot easier to do an electrical heating instead of fresh saturated steam injection heating that we use on a bigger scale. Obstacles and problems we have found, not really. The process itself works fine with beach wrack, with seagrass, as well as other waste biomasses like green and garden waste and waste from the brown bin. We have tested food residues from hotels and restaurants. All that biomass can be converted to biochar. It works fine. The problem is when you have a biomass that comes, easily said, dirty, like beach wrack that comes with a lot of sand, and you cannot there's no good way to separate the sand. It passes the VTC reactor unchanged, which means that in the biochar we find a lot of inert material like sand and salt and clam shells and things like that. And since we are focusing on the utilization of biochar as a solid fuel, our main concern obviously is the calorific value, so the energy that you can get out of it when you burn it. And that brings me to this little example. On the right side, you see dry matter from mixed beach wrack. That's the green bar. That has a calorific value of almost 20,000 kilojoule per kilograms. That's actually not bad. That's somewhere in the area of wood. But this is dry or pure organic dry matter. And if we carbonize it, we get to around 24,000, 25,000 kilojoules. So around 20-25% improvement. But for the pure organic dry matter, if we calculate the ash content in this example, more than 1/3 of the beach wreck came in forms of ash, as we say in coal analysis. You could say inert material that's not only sand, but most of it is sand. And then you carbonize the material, you still have the ash, the sand in the biochar. And since the biochar as well as the sand are pretty fine particles, they are very hard to separate. You cannot screen them off from one another. And therefore, the quality of biochar that we can generate out of dirty biomass, or sandy biomass in this case, is not as good as from, for example, pure wood that we carbonize, or from waste collected from the brown bin, the bio waste from households. That also has some inert materials, but not in this to this extent. Well, that was it already. So thank you very much, and of course I'm open to questions.
Okay, thank you very much. I don't see any on Slido.
May I put a question?
Yes.
Have you tried to make some kind of, I mean, you are heating up the material before the pyrolysis process. Have you tried to separate the sand in heating up? We have experienced that 22 degrees, a lot of sand is leaving the algae.
And then you get it out how? You can screen it off or something?
We're getting it out with the water. I mean, this is the water. This is not, maybe not your business, but I think there could be an idea to the pre-treatment, the preheating you are doing it before you put it into the pyrolysis may be a way to get rid of the sand.
Okay. No, we have not. All we tried was some screening. I mean, it's if you have very coarse beach wreck, like mostly seaweed and things like that, you can screen it. Of course, you can screen off a good part of the sand, but not beach wreck is not pure seaweed or something. And sometimes beach wreck can be very fine, almost slimy liquid particles, and that stuff is very hard to get away from the sand. If you look at my thank you very much screen, I don't know if it's still visible.
Yes.
For example, I made that picture on the island of Rügen last year in August, I think, and that stuff was pretty fine, almost liquid. No way to get sand out of that.
No, of course
you
not.
could try to float the sand off like you do in a wastewater treatment plant. But well, there has to be for us the problem is the amount of beach wreck collected, at least in our case study area, is not big enough so that it could be really economically interesting to put too much work into that, since of course our main focus is plant building, engineering and plant building. So we need to sell VTC plants, and there is if you want to use VTC as a solution to get rid or to recycle, thermically recycle beach wreck, you can do it if you co-treat it with other waste biomasses. That becomes economically feasible options, and then in the biochar mixture, the sand from the beach wreck doesn't play that big of a stake anymore.
So in this laboratory scale, you use electricity to heat up this 15-liter reactor. But how would it look like in, let's say, real scale? What type of capacity are we talking about? And what's about the energy balance, considering that perhaps that the seaweed is wet when it's arriving?
We have made tests for the energy balance from very dry material like dried wood towards very wet material like fresh pressed digestate from biogas, or you know, I'm not aware of the English word, trester from beer production, things like that. Very wet stuff. Also, food residues came with around 80% moisture. We usually calculate it in the amount of biocoal that we get out of it. Our idea is to feed to fuel the process by burning our own biocoal. So we take a part of the product and use it in a furnace, in a steam generator, to produce steam. Then the steam, fresh steam at 25 bar, is injected into the reactor. That's the heating that we usually do instead of the electric. And we are between 5% of the coal we get out of the biochar that we get out of the production for very dry biomass input, and up to 24-25% for very wet biomass. So we still get like 75% biochar out of very wet material.
Okay, thank you.
But it only works if you have a plant big enough, of course.
Yeah. Okay, so now we have come to the end of the conference. It's 3 o'clock. So of course we want to say thank you to all the speakers, to the panelists, to the participants, and of course the organizers behind it. I don't know, Angela, if you want to say some concluding words, or Christine.
Thank everyone who took their time and shared their expertise with us, and that was learned a good bit today. So thank you.
Okay, and I would like to use the occasion to actually thank our moderators. You have done such a great job, and it turned out into in a really good and interesting event, as we have hoped for, and we have practiced a bit, and there were a lot of preparations involved in this event. And in that sense, also thank you very much for the panelists who have built this conference. And I think it was really interesting, and I think the audience will agree. Also, thank you to the active audience. You have taken part quite nicely, asking interesting questions and making this event more lively. Which is quite complicated in this virtual times that we currently have. So yeah, thank you very much to all of you. And bye, and see you maybe next time. I mean, there will be at least one more conference. I haven't mentioned this during my presentation, but at least one, maybe even two conferences will be part of the coastal biogas project, and maybe we can welcome you again the next time.